Okay, so just to introduce ourselves quickly. We are Patrice and Stéphane. We are both located in Lyon, in France, in the development center of the software Simcenter Sim. On myself, I am working as an application specialist for applications related to hydrogen, fuel cells, electrolyzers, renewable energies, when Stefan is a business developer for Simcenter System Simulation. If you have any questions during the presentation, do not hesitate to use the chat. During the session we had this morning, we had a very limited time for question and answer at the end of the presentation. So do not hesitate to use the chat, and you have also our contact on this slide. So do not hesitate to also to send emails. To send us emails after the presentation. So I will first introduce quickly what is system simulation. So system simulation is a part of the Simcenter portfolio of Siemens Digital Industry software. System simulation make it possible to capture all the physics of a system in a single model. So you can have mechanical components connected with electrical systems, with fluid pipes, valves, with thermal exchanges, and you can, in the same model, capture all these phenomena. All the models are based on macroscopic parameters. That means that you do not need to know the detailed geometry, the detailed physical properties of the materials before running a simulation, but you can really use system simulation early during the project in order to be able to evaluate different technical solutions, different architectures, and go directly to the right decisions. You will find off-the-shelf components in our libraries, so that means that you do not have to code yourself the equation of the physics, but they are already encapsulated in existing models that are validated, documented. And with this macroscopic parameters model, on top of the fact that you will need just a few parameters to run your models, the simulations are quite quick, especially if you compare it to CFD simulation, for instance, or 3D mechanical simulation. So you can perform a long scenario simulation in just a few seconds, or in the worst case, in a few minutes, and that helps to evaluate many scenarios, many design options very quickly. And in the software platform, you will not find only libraries of models, but you have many tools that helps to prepare your simulation, as well as to analyze your simulation results and understand them with post-processing and animations. I will show you a demo later during my presentation. Now, regarding hydrogen applications, that's a typical example of application where system simulation is helpful, because, for instance, if you consider the production of hydrogen or the usage of hydrogen in a fuel cell electric vehicle, you will have a combination of physical phenomenon, fluid flows, thermal exchanges, electrical components, mechanical ones, and also with control. So it's a typical mechatronic system. And typical questions that you can answer using system simulation are, for instance, what is the best architecture for my system? What is the best sizing for each of the components? What is the best way to control my system and the different subsystems? You can, thanks to system simulation, better understand how subsystems interact together, and especially in very complex systems. You can evaluate how your system will behave considering multiple scenarios, for instance, the actuation of a component such as a valve, a compressor, a reactor. You can also evaluate what the behavior of your system during severe operation conditions or a failure. You can evaluate if there are any risk of overpressure or temperature impacting the safety. You can predict how much renewable energy or hydrogen you can produce with your system. You can, for instance, predict what is the time that you will need to refuel a vehicle tank, or how much hydrogen or energy will be consumed by your system. So these are just some examples of questions that you can answer using simulations. Regarding the application, so here are 6 examples of applications that we are already used to address with hydrogen. So it starts with hydrogen production, especially green hydrogen production with renewables energies. It can be the transportation of the hydrogen in long piping systems. It can be the refueling or the hydrogen dispenser in refueling stations, or the usage of hydrogen in different kind of systems, from fuel cells, turbofan of aircraft, combustion engine, for instance. And let me show more into detail the first example of application. So here we have a model that is used to capture the behavior of a complete plant, where we are first producing green electricity with different fluctuating sources: wind turbines, solar panels, and wave converters. And depending on the operating conditions, we can predict the dynamic evolution of the electricity that we can produce. Then this electricity is supplied to an electrolyzer, and with the electrolyzer model, we'll be able to predict how much hydrogen is produced from the electricity. Then we can model the hydrogen storage system. So for instance, in this model, we have several tanks, high pressure tanks. We are using compressors to compress this hydrogen, so we can predict the energy that will be consumed by the compressors. We can size hydrogen tanks accordingly to the quantity of hydrogen that we produce. And last but not least, here we have a fuel cell system that make it possible to produce electricity again when the power delivered by the renewables is not enough for the load. Simulation of a complete year are very fast, so you just need a few seconds to perform simulation of a complete year. You can analyze your results monthly in order to, for instance, analyze how much energy and how much hydrogen you will produce month per month. The second application that I will introduce is a refueling station for hydrogen. So with different challenges. So with a refueling station, you will need to be able to deliver hydrogen as quick as possible in order to be comparable with conventional vehicles. But you will also need to consume as less energy as possible with the compressors that are used to compress the hydrogen up to 700 bars at the level of the vehicle tank. You will also have to consider safety and, for instance, controlling the best way temperatures, pressures, and flows. And last but not least, you have to design the system in order to be profitable. So you need to reduce the cost of the system. So you have to define the best sizing for your different components, and you can also, thanks to simulation, make it more reliable, so you can also reduce the cost of maintenance. So typically with the system simulation, you can evaluate different kind of architectures, different kind of sizing for the components, as well as different control strategies. Now let me switch to the software to show you the corresponding model. But first, I will show you quickly. Here you have a list of libraries where you can find all the models. So you have both models or libraries dedicated to the basics of physical domains like fluids, thermal exchanges, electrics, and so on. But you have also more applicative libraries dedicated to fuel cells, to combustion engine, to batteries, to cooling systems, and etc. So here is a model that has been built using the different components from the libraries. And at the left side, you have a tube trailer with a large volume of hydrogen at 200 bar. And the goal is to reach 700 bar in the vehicle tank, thanks to two compressors that can be used together. As compression usually warms up the gas, we have to cool it down. So here we have two heat exchangers. And we have a last one close to the tank in order to be sure that we will not damage the liner inside the high pressure tank for hydrogen. So now let me run a simulation. Yeah, I am compiling the model. That's not really interesting, but now I can run the model. And the simulation is performed on my laptop in less than 1 second. So you can see that it is very quick. And in order to analyze the results, so the first interesting capability in AmSim is to use the sketch animation. So I can launch the animation, and you can see with some colors on the different pipings, the dynamic evolution of pressures, for instance, in my system. I could also use the same capability to visualize the dynamic evolution of temperatures. What is also interesting is to draw some plots. For instance, here you can see the dynamic evolution of the pressure in the vehicle tank with the red line. And you can see that I am reaching 700 bars after a bit more than 8 minutes. And you can see here the quantity, the corresponding quantity of hydrogen, so close to 5.5 kilograms, or something, the right order of magnitude for passenger vehicle. Here are, for instance, some additional plots for to visualize the power and the energy consumed by the compression. And here the evolution of the power that we need to, the heat that we need to remove with the heat exchangers. So with this kind of model, you can size your different components, the cooling systems, the pipes. You can predict the time to refuel your vehicle. 8 minutes, it's a bit long. So what is also possible is to evaluate an architecture where we are using buffer tanks at different level of pressures. And here I have one component used to control the different valves of my system. And if now I change my strategy in order to use these buffer tanks, I run a new simulation. And if I plot again my simulation results, I can see that now, thanks to this new strategy and the buffer tank, I can refill my tank in less than 5 minutes. That is more comparable to what we do today with gasoline or diesel vehicles. You can see also that once the vehicle tank is full, I use the compressors in order to refill the buffer tanks of my system. And still I can visualize the energy consumed for the compression or the heat that I need to remove with a heat exchanger, and I can easily compare the result with the two strategies or the two architectures. If you have any questions still, do not hesitate to use the chat. The last application that I will introduce before letting the floor to Stéphane is the one with a fuel cell system. So we have in AmSim a long experience with PEM fuel cells that are integrated in passenger cars, for instance, or in trucks. We have also more recently developed some capabilities for solid oxide fuel cells that can be better used in stationary applications or also for marine applications. So here you have a model of a ship using a fuel cell to power an electric motor that will generate the rotation of the propeller of the ship. So in Simcenter Sim, you can define different scenarios, like different sea routes, and you can, for instance, evaluate how much hydrogen you will consume for the defined sea routes. And you can also integrate the fuel cell with the rest of the system. So here the fuel cell is in fact supplied with some hydrogen that is extracted from methane using a reformer. So here we are simulating the reformer. What is interesting to know is that the reformer will consume some heat when the fuel cell is generating some heat. So in this system model, we can evaluate how the power generated by the fuel cell can be supplied to generate or to make it possible to have the right reaction in the reformer. In the same way, the fuel cell is producing some water, so we are also simulating the water network, where we will capture the water at the outlet of the fuel cell in order to deliver it at the inlet of the reformer. I now let the floor to Stefan for the next slides.
So Simcenter Sim actually is an open platform, and it's a key point. We try to connect to any third-party tools of software. So that means 3D tools or real-time targets or optimization tool or whatever. Among all these tools, we have connection with the PLC. So it's some works we started in 2015, so 8 years ago, with our colleagues from Factory Automation. And at that time, we found that it would make sense to connect Simcenter Sim with the Siemens PLC. So we released a product which is called Automation Connect. And the Automation Connect is an intermediate software that allows to exchange the inputs and outputs between the two worlds. So let's say the mechanical worlds and the automation worlds. And doing so, you can have all these exchanges and synchronization regarding the real-time aspects. So today we support most of the PLC available on the market. So that means the Siemens PLC, but also the non-Siemens PLC. We have several protocols, communication protocols available, like OPC UA, OPC-DA, Modbus TCP, and to address two main use cases, I would say. So it's two ones highlighted in green. The first one, HIL, is hardware in the loop. And in that case, you exchange directly the data between the real PLC, so the physical PLC, and the Simcenter Sim digital twin, which is the model of the simulation system that you represent. And the second use case is the software in the loop, SIL. In that case, you make some emulation of the virtual PLC, and you connect with the digital twin in Simcenter Sim. So doing so, you can have some concurrent engineering between the two departments, so the mechanical department, automation departments, and you can investigate some scenarios like the impact of a code modification regarding safety or productivity. You can make decisions depending on the operating points, create some interactive dashboards or some failure analysis. Initially, we started more in industrial machinery, food and beverage. So that means with a hydraulic press or packaging machine with plastic films, bottle filling machines, and so on. And now the traction with our factory automation colleagues is more with converting system or battery production machines. And if we go more into the details, so it's the picture here to see how you connect. So in yellow, you have the digital twin, which is done with Simcenter Sim. In the middle, in blue, the communication with Automation Connect. And at the right side here, it's for the virtual part of the PLC. So you use a PLC Sim Advance, and you exchange between PLC Sim Advance in TIA portal with Simcenter Sim with Automation Connect in the middle. And for the second case, hardware in the loop, the only difference is at the right side. with the automation part where you have the real PLC here, so the controller, CMT unit, and the protocols like OPC-UA, for example. And you combine both together. So you exchange data, it's a live streamlined data exchange with the simulation running extremely fast in real time to be well synchronized with all this data. If we go a bit more, we extend the scope of the Simcenter portfolio. For system simulation, we have another tool which is called Simcenter Flowmaster, and it's really appropriate for the fluid transport infrastructure. If we look at this picture here, you can see you have longer pipes, either for the hydrogen pipelines or for the water networks to go up to the electrolysis plant, or some natural gas pipe networks here where you combine in the mixing station. And these pipelines are longer, like several hundred of meters or kilometers. And for doing this, Simcenter Flowmaster is more appropriate. Here is an example with Open Grid Europe, which is a German company, and they use Simcenter Flowmaster for this typical case of hydrogen transportation. So at the end, it's a matter of checking the requirements, like ensuring the safety, also retrofitting existing installation, or some requirements regarding gas flow dynamics or peaks of pressure that you need to ensure, things like this.
We have a fuel cell. We started to develop fuel cell simulation capabilities now 15 years ago, but also more recently we have developed capabilities for the other applications related to hydrogen. So we have customers using AMSIM for the design of refueling stations. We have customers using Simcenter Flowmaster for the hydrogen transportation in long pipeline systems, also for the simulation of the CO2 transportation. The French company designing hydrogen generators based on the combustion of hydrogen instead of the combustion of diesel or gasoline. And finally, here are two examples of customers using AMSIM for electrolyzer systems. We are also with our software product involved in different R&D projects. So I will mention here on this first slide a project for the automotive and the truck applications, where the goal is to develop some fuel cell systems which are more reliable with a longer life expectancy. The leader of the project is Vitesco Technologies. Other partners are IFP Energy Nouvelle and also Alstom Hydrogen, who is willing to integrate its own fuel cells in their trains. But we also have R&D projects about fuel cells and hydrogen in the aerospace industry. So you can see here three projects. The first one, at the left one, is focusing on the combustion of hydrogen in gas turbines. But the scope of the project is also addressing all the cryogenic storage of this hydrogen and the delivering of the hydrogen from the tank to the gas turbines. At the right side of the slide, you have the newborn project. That is also a really interesting project. As in this project, the plan is to integrate fuel cells and fuel cell systems into aircraft. At the bottom of the slide, you can see the different partners of the project. So you can see some interesting names such as Airbus, Leonardo, Honeywell, PowerCell, just to give a few of them.
Okay, so this is just like a summary of what was explained before regarding the different use cases. To also position a bit the Simcenter portfolio, so we mainly focus on Simcenter AMSIM, and you can see for all these 5 use cases here, you will find Simcenter MSIM, except maybe for the fleet transport infrastructure in the middle, where it's more appropriate to use Simcenter Flowmaster. And if you want to go a bit more into the details of the components or the valve or the T-junctions, you can use also StartSM Plus, which is the 3D CFD tool. So CFD is computational fluid dynamics, really to capture the streamlines or the velocity profile within the components. If we look at the left side, maybe something to mention for hydrogen production electrolyzer is that we showed actually some fluid part, thermal parts, controls part, but we also go up to the electric side with a battery energy storage system, microgrids, DC-DC converters. All this you can also represent in MSIM. The second column is about the source of energies. If you want to go to green renewable energies, you have to represent the wind turbines, the solar, photovoltaics, or even some wave energy converters. This is possible with Simcenter MSIM. So typically for sizing the panels, depending on the weather conditions, the location worldwide, if you are in, I don't know, Tokyo, South Africa, or elsewhere, you don't have the same sunny conditions. Wind turbines also with the driveline, thermal lubrication. You can go into all these details. For the fourth column about storage for tanks and refueling station, maybe something to mention for the tanks. So you can represent compressed hydrogen tanks. So typically this is for automotive industry at 700 bar, but for aerospace industry, the tanks are cryogenic tanks. And you need also to represent some phenomenon like the ball of gas, which is the separation of the parts of the liquid hydrogen and gaseous hydrogen. If you want more details, you can use again Simcenter StartSM Plus for 3D CFD. And if you are interested in the risk of explosion of the tank itself or the layers of composites for the walls of the tanks, you can use Simcenter 3D, which is the tool for the structural mechanics. And for the last column, it's about all the polarization curves, system integration, water, thermal, oxygen management for all the industries. So same thing for system level, it's Simcenter MSIM. If you want to go locally into more details, you can use Simcenter StartSM Plus. 2 slides to conclude. Actually, it's some questions that were in the chat about some go-to-market materials. So here we put some party slider presentation for various topics like hydrogen ecosystem, green hydrogen production, refueling station, fuel cell, and so on. So you can click on the links directly. You can open the documents and download them. And we had also some added some links to some webinars or videos or case studies in this slide. Same idea. You click on the links, and if you have additional questions or use cases, you just ask us. So either Patrice or myself, we have much more materials available. I think that's all.